The types of eclipse form depends on the position, because here the sun is the source of energy, or the source of light energy. Here the sun is the source of light. And remember, members, we look at different types of objects, or different types of sources of light. We look at luminous, we look at non-luminous, then we also went ahead and look at what we call the fluorescence and then the phosphorescence. We said for the fluorescent substance, for them they absorbed and immediately release the energy in form of light. An example we gave like zinc sulfide, and the big example we have is the TV screen that we use. The old screens, not this modern screen you always have now these days. Then we have the CROs, what we call the cathode rays oscilloscope. They're also made of fluorescent substance. Then we have also what we call the fluorescent substance. For them, they absorb energy falling on them, they store it, and then release it after some time. An example, we have like a zinc sulfide. We have calcium sulfide. So those are the substances that we see that. When you look at from your chemistry, when you look at zinc and calcium, they have different. When you look at in their reactivity series, they are different. So you have to take note of that. So we are saying the types of eclipse form depends on the position of either the moon or of the earth. We look at, we say there's what we call the solar eclipse, which we sometimes refer to as eclipse of the sun. An eclipse of the sun is divided into two. What we call the solar eclipse, Then there's what we call the annular eclipse, For annular, the moon is far away from the earth. In other words, is near. The moon is near the sun. Here, the moon is near the what? Near the sun, or far away from the earth, And here the shadow of the moon does not reach the earth. So the umbra, the umbra does not reach the earth, but for this one, the umbra, the shadow is cast on the earth. The shadow is cast on the earth. That's the only difference. But still, the moon is still in the middle. We have looked at those facts. Then we have what we call the lunar eclipse. The lunar eclipse. For lunar, the earth is in the middle. This time is it? The earth is in the middle. And this one takes place only at night. The eclipse one, sometimes we call it the eclipse of the moon. What we call the eclipse of the moon. And takes place only at night. And we discuss the duration of which they takes for its occurrence. When you look at, are you able to see my notes here? We say total eclipse of the moon cast longer than the partial eclipse of the sun. Longer than the total eclipse of the sun, because the earth is bigger than the moon. So which means the earth will block the moon completely. So which means it will take longer time. And we said eclipse of the moon takes place only at night. So which means, in many cases, we don't see it because at that time, most of us were asleep, but it occurs. And scientists are saying it at least occurs twice a month or twice a year. It depending on, because we say this thing, we have no control over them, because they occur naturally. But at least twice a year or once a month, just something like that. But for eclipse of the moon lasts longer than the eclipse of the sun. Like when you remember the one that took place that one that occurred in 2014. Yes, took place because that one is eclipse of the sun, because it takes place during the day, and it does took place in a very short period of time. Members, are we together? Members, are we together?
Yes.
Yes. So take note of that. We said total eclipse of the moon lasts longer than the total eclipse of the sun, because for the moon, the earth, which is in the middle, is larger than or is bigger than the moon. Is bigger than the moon for the sun. So you find that the earth will block the moon completely. That's why we say that the eclipse of the moon or the lunar eclipse lasts longer compared to the eclipse of the sun. That is it. So that's what, just a quick reminder. Remember, is there any question on eclipse before we move to the next application of rectilinear propagation of light? Is there any question on eclipse? Yes? Members, is there any question on eclipse? Please talk to me. Let's move together. Members, is there any question on eclipse before we move?
No.
Eclipse is clear, right? Is clear, right? Okay. Okay, now let's look at the pinhole camera. Pinhole camera. Pinhole camera. Subheading. Pinhole camera. Pinhole camera. Who is that one really? Who is that? Pinhole camera. Subheading. The pinhole. The pinhole camera. The pinhole camera. The pinhole camera. So pinhole camera is one of the applications. Is one of the application of rectilinear propagation of light. We said because light travel in a straight line, so which means if it's being obstructed by any opaque object, it will block off the path of the light. And when they block the path of the light, it produces three effects. And one of the effects is we have said is shadow. Then the second one is eclipse. Now the third one is the pinhole camera. The third one is the pinhole camera. Which is the last application of rectilinear propagation of light. So members, can we draw that? Or before we draw that, can we write this statement down? Let's write this statement down. We said a pinhole camera is not on the screen, please. It's not in the notes. I believe you all have these notes. I'm adding on what you already have. These notes, you have them. So when you check your notes, make sure that you move on and on, because when we come here, we just explain the notes that you already have. I expect by this time, everyone to have downloaded the notes from the website or from the WhatsApp message. From WhatsApp, we have been sending some of this work on WhatsApp. So I believe by this time, everyone must be having the notes. So when we come here, I just explain this concept and I just add on few things just to make us understand better. Are you together, members? Are we together? So we said a pinhole camera is also an application of rectilinear propagation of light, that is light travels in straight lines. Light travel in straight line, full stop. A pinhole camera is made up of a light tight box with a small, with a small, or sometimes we just call, that's why we call it pin, which means very small, small or pin, all in front, full stop. A pinhole camera is made up of a light tight box with a small or a pinhole in front, full stop. The inner surfaces, are painted. The inner surfaces are painted black, so that no internal reflections, of light occurs. No internal reflection of light occurs. Full stop. Continuation. The face opposite, the pin, or the small hole, opposite the small or the pinhole, as a tracing paper, to act as a screen, a screen. Members, are we together?
Yes. Yes, teacher.
Okay. So, by the way, after this lesson, I'm giving you a project. I'm going to give you a what? A project. You have all these materials around you. You are going to design for us a pinhole camera, and then you come and so next, when we meet on Monday, we are going to explain how it works. Okay? Are you together? Today we are just going to talk about the theory. So after understanding the theory, I want you to go and demonstrate it using the available materials there. Get a box, get a small box. Then inside it, you can paint it black. If you can't paint it, then just get a black cloth. Get a black cloth and align it inside. Align it what? Inside the box. Then create a hole. You can use a nail. Just use a nail. Members, are you following me? Are you getting me?
Yes.
Yes, get a nail. Then create a hole. Now, the source of light. We have talked about different sources of light. Okay? We have talked about, you can put a bulb there, or you can even use, you can focus a tree, you can focus a building, you can use it to focus anything. You will see the nature of the image that is going to be formed. That's assignment I'm leaving with you. Okay?
Yes.
Yes. So then on the side, which is the face, which is opposite the screen, after creating the hole or the pinhole, or what we call a small hole, the opposite side, get a tracing paper. How are you going to, if you don't have a tracing paper, members, don't worry. What you can do, just get the plain paper. Do you have plain papers at home? I believe you have them. Okay?
Yes.
Then just pour some cooking oil on it. Pour cooking oil on it. When you pour cooking oil on it, what you have formed, that one is tracing paper already. It's going to act like a tracing paper. Are you together?
Yes.
Yes, you just pour cooking oil on the paper. It will form a tracing paper. A very perfect one. That's how you improvise. Okay? Members, is it okay?
Yes.
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 Yes. Good? Full stop? Full stop. After that, now let's look at how does it operate? How does it operate? How does it operate? Mechanism. Let's look at mechanism. Mechanism. How does it operate? How does it operate? How does it what? Operate. Let's say, members, who can tell us from just a simple description I've given here, how does a pinhole camera operate? Or how does it work? Who can give us?
Let me try.
Yes, please. Lynette.
Light from that object to enter the pinhole camera through the small hole, forming an inverted image.
Forming an inverted image on the what? On the screen. Forming an inverted image on the what? On the screen. But how will that light travel? We know that light travel in a straight what? In a straight line.
Straight line.
So you are going to say, I'm giving answer for that. I'm giving answer for that. We start by saying it works or operates. It works or operates on the mechanism that rays of light from the various parts of an object outside will travel in straight lines through, like Lynette have said, through the pinhole onto the screen, hence forming. Lynette, forming what? Lynette, what have you said? Forming what?
Forming an inverted image.
Good. Forming an inverted image. Forming an inverted image on it. Members, as simple as what? That. As simple as that. That's how it's, if they also explain or describe how a pinhole camera works, you just say it works on the mechanism that rays of light from various parts of the object outside will travel in straight lines through the pinhole onto the screen, hence forming an inverted image on it.
Teacher.
Yes, please.
I thought the image is real. It's real.
The image is real but inverted. Good. The image is real but inverted. Okay? Okay? The image is real but what? But inverted. Or you can even add it here. You can even add it here. You said, hence, forming real and inverted image. Forming, you can say, forming real. You can add the word real and what? Real and inverted. Yes. What do we mean? We shall look at what are real images. We shall look at that. When we talk of real image, which means you can see it on the screen. A real image can be seen on the screen, members. Are we together?
Yes.
That's why we call it real. But the image that is formed on the screen is inverted, is upside down. The image is upside what? Is upside down. Inverted means is upside down. Are you together?
Yes.
Now, members.
Yes.
Can you draw this one? Can you draw the structure? Now, let's look at structure of a pinhole camera. Structure of a pinhole camera. Structure of a pinhole camera. Can you draw for me that? Just draw it in your book. Draw it in your book. So what is our object? Our object is we are using above. We are using a what? You can use anything. You can use a tree. You can use a person. You can use a dog. You can use anything as long as it's an object. Are you together, members? You can use anything. Okay?
Yes.
Yes. So for this case, we are we are using above. Or what we can do, we can present objects just by drawing straight lines. So that's what I'm going to draw here. That's what I'm going to draw here. So we start by drawing. Let's draw the box. Let's draw the box. Or let's first write this statement. We said it consists of a closed tight box, with a small or pin hole on face and a screen of tracing paper on the opposite face. Full stop. So that's the opening statement. After that, now let's draw it. I'm going to draw a simple one. I'm going to draw a simple one. So I'm going to draw a box. We all know how to draw a box. Let me draw it in a simple way. That's the box we have. That's what we have. That's the other face, which we can't see, so we use dotted line for that. We use a dotted line for that. So that's my box, member. That's my box. So I'm assuming the pinhole is here. The hole is there. Now the object is somewhere here. The object is somewhere here. The object is somewhere here. In front of it. Something like that. That's our object. So to put that, I'm using that one as our object. So the object is standing upright. That's our object. So rays of object from the top. So we'll pass through. We'll pass through the pinhole. We'll pass through the pinhole. We'll pass through the pinhole like that until it comes to the opposite face, which is there. Then also from there are very many rays passing by, but we are taking only these two from top and bottom. Right together. We are taking top and what? Top and the bottom. Top and inverted. I mean top and bottom, sorry. I want to draw a good one. So there we are. So this is our image. So it's inverted. You see the top is coming down. So the image is what? Inverted. So don't forget to put the arrows, the arrow direction of the light, like that, like that. Members, have you seen that? Members, have you seen?
Yes.
Yes.
So that's how we draw it. This is it, our object. This is the object. Then this is the what? This is the
Image.
image. Then this one is the pinhole. That one is the pinhole. That is the pinhole. Then this is the. Then this is the box. That's the box. Now, members.
Yes. Yes.
So when you look at this, let's investigate this. Now, this is my object. I want us to measure the height. So when you measure this one, I want you to see. So when you look at this one, this is it. Is around 3. Is 2.8 centimeters. Now, when you measure this one, you see that only what? 2.5. So what has happened, members? What has happened to the size of the image? The image is smaller, not so?
Yes.
So what do we say? So when the image is smaller, we said is what? Is diminished. We said is what?
Diminished.
Yes. So we shall look at that one also later. Then there's also something I want you to see from here. There's something I want you to see.
Teacher.
Yes. Now, members,
Let me.
Yes.
the distance, okay? Yes, please.
That means that the image has to be smaller.
We shall look at that one. The size of the image depends on the position of the object, okay? So if the object is close, to the pinhole, the image form here is going to be bigger, okay?
Yes.
Yes, but if the object is far away from the pinhole or from the pinhole camera, from the pinhole, the image form here is going to be smaller, okay?
Small.
Okay?
Yes.
Yes, we shall see that. Now, members,
Yes.
the distance from the object to the screen, that one we use letter O. We use letter U, sorry. We use letter what? Letter U. I sing it there?
Yes.
Yes. The distance from the object to the pinhole, that distance is called the object distance. Then the distance from the pinhole up to the screen, up to the what? Up to the screen. That distance is called the image distance. It's called the image what? The image distance. The image distance. Then the height, the length, this is what we call the object height. This is what we call the object what? That's the object height. We use H0. Then this one is what we call the image what? This is the image height. Members, let me hope you're able to see my work clearly there.
Yes. Yes.
Good. So we said where H0 is the object height. Then HI, we shall look at this. All these one are on writing because they are going to help us. So that is the image. Image what? Image height. Then U is the object distance. Is the object distance from the screen. I mean, from the pinhole. From the pinhole. Then V is the image distance. Is the image distance. Is the image distance from the pinhole. From the pinhole to the what? To the screen. So that distance is called the image distance. Is it clear, members?
Yes.
Good. Good. Then the next thing is a description of the image. How do you describe the image? Description of the image. Subheading, description of the image. Description of the image. Description of the image. Description of the image. So how do we describe the image? Description of the image formation. Description of the image formation. Description of the image formation. So we said the image is real and inverted, like someone have already said that. The image is real and inverted. Each point of the object, each point of the image on the screen will be illuminated. The illuminated, which means there is light on it. Which means the image will be illuminated, which means there will be light on it, only by the light traveling in a straight line from a particular point. From a particular point. From a particular point. That's how we describe the image form. Are you together, members?
Yes.
Yes. Now let's look at the effect of image position. Effect of, let's put it like this, effect of object distance. Effect of object distance from the pinhole. From the pinhole of a pinhole camera. Members, if you remember, when I was explaining this, I said, if the object is far away from the pinhole, what will happen to the image? The image form will be what? Diminished. No, sir? Will be smaller than the object, right? But if you bring the object closer to the pinhole, which means you are reducing this distance. You're reducing the distance between the object and the screen. The image form here will be what? Bigger.
Magnified.
Will be magnified. Okay? Yes.
Yes.
You write it. One. We said when the object is moved, closer to the pinhole, when the object is moved closer to the pinhole, comma, the size of the image formed, is increase. Is what? Increase. In bracket, we use the word what? Is what? Magnified. Is magnified. Is magnified. But becomes less bright. But become less what? Less bright. Since the same quantity or amount of light, is spread over a larger area on the screen. Over a larger area on the what? On the screen. Are you together, members?
Yes.
Yes. Then I think for the second one you can write, not so? When the object is moved farther away from the pinhole, what will happen? We said what will happen? Members, when the object is moved far away from the pinhole, what will happen? The size of the image will what? Will be?